Hey, welcome back. This is lesson 3 in Unit 8. This one's all about factoring to find real root and zeros. So um, we looked at factoring in the last lesson. We looked at some special patterns. Let's start by reviewing that. We knew this before. We've seen this now for a couple of units. This is a minus b times a plus b. And this is our perfect square trinomial. This is a plus b squared. And this is a minus b squared. The difference of two cubes, though, is a minus b. And then we square the a, and you multiply a and b together, but you change the sign, and then b squared. And the sum of two cubes is pretty much the same thing. This time it's a plus b, and then a squared, but then we subtract ab plus b squared. And you should probably, distribute this out and confirm that this does indeed simplify back to a cubed minus b cubed, but I'll leave you to do that. We also discussed the art of factoring by grouping. The grouping technique is something that works for a lot of four-term cubic polynomials, the ones we'll see in these lessons here. We'll learn in a later lesson how to deal with when it can't be grouped. You can group, you can use factoring by grouping just in general whenever this to this is the same ratio as this to this. In other words, they would have the same fraction. But they have to somehow be in the same ratio so that you get the same group common factor to the groups. We also looked at what to do when a polynomial is in what I call quadratic form. Quadratic form is when you have the look of ax squared plus bx plus c, but the exponents are something bigger. And the secret is whatever's on this x here, this has to be half of it. So we saw things like x to the fourth plus 3x to the second minus 4. We can factor that because 4, then 2, and then nothing. Okay, let's apply the factoring to find the real roots of some polynomials. Well, a root is just simply a solution to a polynomial equation. So on this one here, we got 4 terms. Let's try grouping it. And when you group, when there's a minus in between your groups, you really want to think of that as plus a negative. So I'm just going to go in there and add that, okay? Now I'll factor out a common factor. And that'll give me x cubed divided by x squared is just x. When you pull x squared out of x, you get 1. Here, I have to pull out a negative. When you're grouping, if the first term is negative, pull it out. So I pull out a negative 9 times x minus 1. And while I'm on the subject, you should factor out, even if it's just a 1 that's in common, you would factor out a 1 when grouping. That's very important. All right, so now we have x... Oh, I'm sorry. I factored out a negative 9 here. This should be a negative 9. That makes positive. This should be a positive. There we go. Because they have to be the same. And now they are. You see, I've got a common factor. I've got 2 terms. They're big. I've made them into 2 big terms, but they've got an x plus 1 in common. So I can factor out the x plus 1. And then I'm left with x squared minus 9 equals 0. And we can factor this as x minus 3, x plus 3. So you see, not always, but sometimes you can go further. Then I can set each one of these factors equal to 0 and solve them, just like we did before. So same kind of idea here. This gets me x equals negative 1, x equals 3, and x equals negative 3, because any one of those values would make one of these factors 0. And 0 times anything, no matter how many factors there are, 0 times anything is 0. So I know those are solutions. So our answers are negative 1, 3, and negative 3. All right, let's check out the next one. All right, when we are dealing with polynomials, just like with quadratic functions, we want to get this equal to 0 first. So we're going to say x cubed. I'll move this over here, making it minus 4x squared plus x, and then I'll move that 4 over as well, subtracting 4 from each side. All right, let's group here and here. I'll factor out the x squared, and I'm left with x minus 4. And we talked about this earlier. It really helps you visualize it if even when there's not a GCF in a group, factor out a 1. So you can see the two groups now. I've got an x minus 4 in common to both ones, and then I have x squared plus 1 left over. Now I can set these equal to 0. I can't factor this, though, because it's not a difference of two squares. This is x equals 4. I can subtract 1 from each side and take the plus or minus square root, right? Now, if we're dealing with complex numbers, we are going to say that that's plus or minus I. Note the instructions, though. Looking at real roots. I don't want to talk about complex roots quite yet. So we're just going to go with that's not real. These are non-real values. So our only real roots is the number 4. All right, let's try the next one. X cubed minus 27 equals 0. All right, this actually is a difference of two cubes. So this is the cube root of 8 is 2. So this is 2x, and the cube root of 27 is 3. Then you remember the pattern. You square the first thing. It's 4x squared. Multiply these two together, but you have to change the sign. So it's plus 6x. And then we square the last number, giving it plus 9 equals 0. I can set 2x minus 3 equal to 0, and I get x equals 3 over 2. You may remember this isn't going to be factorable. It just never is. So we have to use the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4 times a times c, all over 2a. 2 times 4 is 8. So this is 36 minus 4 times 9. So 4 times 4 is 16, and then 9, that's 54. That's 144. So that whatever this is negative, right? 36 minus 144, I'm not even sure what that is. I think that's going to be like a 10, looks like 108. But it's negative because I'm subtracting a big number from a small one. So this is non-real as well. So 3 over 2 is our only real solution. I wanted to point this problem out, though, because this is a really interesting algebra problem. If we're going to look at, we're going to talk about solving these things in lots of different ways. One of the ways people would solve this is they would isolate the x cubed. Okay, and they would take the divide by 8 and take the cube root, and they get the 3 halves. But notice this equation actually did have complex zeros as well that they would completely miss. So it's kind of interesting. This problem becomes a lot more complicated when we're dealing with the complex numbers. Not as simple a change as when we were dealing with just quadratics. Let's take a look at this next one. Again, somebody might look at this and think, oh, I can add 1 divided by 4, but what we really need to do is to factor this. This becomes 2x squared minus 1, 2x squared plus 1. This is a difference of two perfect squares. These are perfect squares here. 4x to the 4th. Any exponent I can divide in 2 is a perfect square. All right, now I can then set each factor equal to 0. And solve. Neither one of these terms is going to be factored. This one's close, but this 2 is not a perfect square. So I have 2x squared equals 1. X squared equals 1/2. I'll take the plus or minus square root of each side. And I'm going to do a little scratch work over here. I've got to take the square root of 1 over 2. And the way we square root a fraction is you square root the top, and then you square root the bottom. But 2 is irrational. An irrational square root, I mean. So then I got to multiply by root 2 on top and bottom. I need up root 2 over 2. So that's the simplified version. X is equal to plus or minus the square root of 2 over 2. Over on this side here, we're going to, after doing some algebra, we're going to end up with negative 1/2. The square root of a negative number is non-real. So our only solutions are the square root of 2 over 2 and negative the square root of 2 over 2. All right, let's do x to the 4th plus x to the 2nd equals 20. Don't be tempted to try and factor this. You've got to get it set equal to 0 first, or it doesn't do you any good. Now that I've got it equal to 0, this is quadratic form. We can factor this. It'll be x squared times x squared is x to the 4th, and then something that multiplies to 20 and subtracts to 1 are 5 and 4. So plus 5 and minus 4. Can't do anything with the x squared plus 5 because that's a sum and that's not a perfect square anyway. But this is a difference of two squares. That factors as x minus 2, x plus 2. Then I can set x squared plus 5 equal to 0, but I get x squared equals negative 5, so x equals the plus or minus square root of negative 5. That's non-real. That's not going to give me a real answer. These other two are going to give me x equals 2 and negative 2. So when I say it's not going to give me a real answer, I don't mean it's not going to give me an answer. I just mean it's not going to be a real number, and we're only doing real roots right now. All right, guess what? It is your turn. Please solve these following. Looks like we got 4 of them for you to do. So pause the video and give it a try. Okay, so remember we're solving over the domain of real numbers because complex numbers add a lot of complexity, hence the name, right? So we're going to keep it simple right now. I hope you tried grouping. Remember, you want to put that negative inside the group because you got to factor it out. I can factor out an x squared here, and that gives me 9x plus 1. And I can factor out a negative 2 here, giving me 9x plus 1 again. I'll then factor out the common factor of 9x plus 1, where I'm left over x squared minus 2. And I can set each one of these equal to 0. I can't factor x squared minus 2. It's not a perfect square. All right, and then I get x equals negative 1 over 9. This one here, I can't factor it, but these are going to be some real numbers, right? So x is equal to, take the plus or minus square root of each side, plus or minus the square root of 2. So square root of 2 is a real number. It's not rational. You know, it's not a pretty nice rational number, but it is a real number on the real number line. The square root of 2 and negative the square root of 2. So 3 answers to that one. All right, let's take a look at this one. We're going to try grouping again. Once again, I got that minus here, so I'll make it plus and negative. I'm going to factor out an x squared, and it gives me x minus 3. I'll factor out a negative 4, and that gives me x minus 3. Then I'll factor out x minus 3, and I get x squared minus 4 equals 0. And x minus 3, this is wonderful because I can factor this as a difference of 2 squares. And so it's easy to see our solutions are 3, 2, and negative 2. Some nice integer roots for us there. Very nice. All right, let's do x to the 5th minus 4x equals 0. It's equal to 0. That's good. We just need to factor it. Remember, the first thing to do when factoring is factor out a GCF. So it becomes x to the 4th minus 4. All right, this is a difference of 2 squares because x to the 4th is an even power. So I can factor as x squared minus 2. The square root of 4 is 2. And x squared plus 2. Can't go any further than that, though. Okay, so I set each factor equal to 0. One of them is going to be x equals 0. And then this gives me x squared equals 2. So x equals plus or minus the square root of 2. This gives me x squared plus 2 equals 0. So x squared equals negative 2. Do you see where this is going? That's not real. So we have 0, the square root of 2, and negative the square root of 2. All right, x cubed minus 64 equals 0. This is a difference of 2 cubes. It factors as x minus 4. The cube root of 64 is 4. And then we have x squared plus 4x plus 16 equals 0. I'll set each factor equal to 0. Remember, this one here is not factorable. Will never be. And so this is x equals 4. Quadratic formula, negative b plus or minus the square root of b squared is 4 squared is 16 minus 4 times 1 times 16 all over 2. Well, 16 minus 4 times 16 is a negative number. These are non-real. And in general, these are typically going to be non-real, at least on the cubic level. So you can almost guarantee that. But it's always a good idea to check. All right. Oh, well, I'll put my answer in set notation. Just the number 4. All right. So using the given graph to estimate the zeros, use the given graph to estimate the zeros of the function. Then confirm the zeros of the polynomial functions using factoring. So let's take a look at this function. I've graphed it for us. This is x to the fifth minus 8x squared. Well, it certainly appears that we have zeros. Remember, I didn't say it, but estimate the real zeros. Real zeros occur on the x-axis. Imaginary zeros would lie somewhere else. So it looks like 0 and 2. Let's see if that's the case. To find zeros, we set the equation of the function equal to 0. And I'm going to factor out an x. I have an x in common in each one of these, so I can factor out x to the smaller of the two powers. So I can bring out an x squared, which gives me x cubed because I subtract the 2 from there. X to the second times x to the third becomes x to the fifth minus 8. All right, this can go even further because this is a difference of 2 cubes. Cube root of 8 is 2. So x minus 2. Then I square the x, get x squared, multiply the 2 together and change the sign, and then square the negative 2 to get 4. So x squared equals 0, x minus 2 equals 0. I get x equals plus or minus 0 is 0, and x equals 2. So 0 and 2. And that's what we have. All right, let's take a look at the next one. We got, looks like my zeros are around negative 2 and 2. Not sure about this one. I'm going to guess 2/3 because of this 3 here. I bet that's going to come into play somewhere, but I'm not sure. Let's find out. Set it equal to 0. All right, I would love it if I could divide both sides of the equation by something to make these numbers smaller, but I don't see a 3 going into all of them. One thing I can do is divide by a negative 1 and get rid of that pesky little negative in front of the x cubed, because that's annoying. There we go. Now I'm going to try grouping this. So we'll group the first 2 terms, and remember that you need to make that plus a negative because you're going to have to factor out a negative, which changes this sign. So 0 equals, we're going to say x squared times 3x minus 2. Over here, I can factor out looks like a 4. So minus a 4, making this a positive 3x and a minus 2, because I'm factoring out a negative 4 from positive 8. So this becomes 3x minus 2. And this becomes x squared minus 4 when I factor these out. Remember, these come together to make that. And then I can factor this further. So I will. This becomes x minus 2, x plus 2. And so when I set these equal to 0, you can see that I will end up getting 2/3, 2, and negative 2. So that's pretty exciting. We got the answer right. 2/3, 2, and negative 2. All right. All right, same kind of deal. I've got a couple of graphs I would like for you to look, just 2 of them. I want you to estimate what you think will be the zeros on the graph, and then please use factoring to confirm your estimates. Pause the video and give it a try. I got 2 of them, A and B. All right, let's see how you did. Looks like 0 and 4 probably are the zeros, right? Because that's where it touches. Okay, so let's go ahead and set it equal to 0 and do that. All right, I'm going to factor out an x squared, and I get x minus 4. Then I'm going to set each factor equal to 0. X squared equals 0, and x minus 4 equals 0. So that gives me x equals 4. And then here, I could take the square root of each side, but it's plus or minus the square root of 0. Well, the square root of 0 is 0. Plus 0 minus 0, it's still just 0. So 0 and 4. So we were right on that one. Next one's probably not as easy. 5, maybe. I'm not sure about these. I'm not sure. Let's find out. X cubed minus 5x squared minus 3x plus 15. And I'm going to factor out an x squared out of the first group, and I'll factor out a negative 3 out of the second group, making this x minus 5 minus 3. And then I get, when I factor out that negative 3, it's going to make the plus 15 a minus 5. So I can factor out x minus 5, giving me x squared minus 3. And then I get x minus 5 equals 0, and x squared minus 3 equals 0. So x equals 5, x squared equals 3, x equals plus or minus the square root of 3. The square root of 3 is, I'm not sure, I can't remember. I want to say it's like 1.7-ish. So that looks pretty good to me. All right. Practice finding the zeros of the following polynomial functions. I did not give you the graph, but these are some pretty kind of unique, different looking ones. So let's give that a chance to kind of get straight in your head. So give it a try, please, and then we'll go over it. Okay, for practice 3.3a, set it equal to 0. This is already factored. There is no reason for you to try and multiply this out and then factor it again. It's already factored. Just set each factor equal to 0. And you may say, well, that's x plus 2 squared equals 0. But then when I take the square root of both sides, I get x plus 2 equals plus or minus 0. So in general, when we're finding the 0, we can kind of ignore that squared there and say that the answers are going to be 0, 3, and negative 2. All right, let's set this equal to 0. This is factorable. Let's take that further. X minus 2, x plus 2. This next one is not, because 12 is not a perfect square. So then we have to set each one of these things equal to 0. And we can solve. We got x equals 2 and x equals negative 2. This one here I'll have to use square roots on, so I move the 12 over. And then I do plus or minus the square root of 12. I can simplify the square root of 12. That's 4 times 3, and the square root of 4 is 2. So it's 2 root 3. So our solutions are 2, negative 2, 2 root 3, and negative 2 root 3. All right, letter C, or h of x. Letter C, but h of x. Okay, so we're setting it equal to 0 because we're finding the zeros. Now, it looks like a pretty scary polynomial because it's got x to the fourth, but look, there's an x in all 4 terms. Let's factor it out. X cubed minus 5x squared minus 2x plus 10. Now that we've done that, we can factor this by grouping, I bet. So let's do that and make that plus a negative. So I get x squared out of the first group, giving me x minus 5. Take out a minus 2, and I get x minus 5. Now, this becomes x times x squared minus 2 is the first group, and the second group was x minus 5. Because I pulled out these 2 5s and put them there. All right, now I can't factor x squared minus 2, but I can set each factor equal to 0. And you can see that our solutions are going to be 0, 5. And this one here, I have to do plus or minus the square root of 2. So my answers are 0, root 2, negative root 2, and 5. All right, letter D. Okay, once again, it's already somewhat factored for us. X cubed minus 8 is a difference of 2 cubes. X minus 2. And then this is x squared plus 2x plus 4. Remember, you have to multiply together and change the sign there. 9x squared minus 16 is a difference of 2 squareds. That's 3x minus 4, 3x plus 4. Now we set each one of these things equal to 0. That's going to be imaginary, so I'm actually just not going to do it. Feel free to check that on your own, but those will be non-real. X equals 2. This will give me x equals 4/3 when I add 4 and divide by 3, and this will give me a negative 4/3. So those are our solutions. 2 4/3 and negative 4/3. All right. Got to find the zeros of this one now. We have 5x squared minus 3x cubed. Set it equal to 0. Let's factor out a greatest common factor of x cubed. Ooh, no, the smaller of the two, x squared, is the biggest I can take out. So it's just a 5 minus 3x. Then I set each factor equal to 0. This will give me 5 equals 3x. So 5 over 3 is x. Square root is 0. Plus or minus doesn't matter. It's just 0. So our answers are 0 and 5/3. All right, for fun, on the x, what I'd like you to do is I'd like you to use just your intuition of what the graph should look like and find the zeros and see if you can't line the zeros up and figure out what graph goes with which. So you can always check by graphing it on a calculator or on Desmos, but give it a try just for fun since we'll be talking about graphs in the coming up lessons. See you next time.